right, so 64 is complex fractions and complex numbers. The word complex means totally different things here, okay? So complex fractions is just fractions within fractions, like we have right here. Complex numbers, however, anybody know what complex numbers are? It is something you guys know, but you may not know the word complex numbers. All right, so complex numbers are just imaginary numbers. It's the same thing as all the i's that you already know, which is the square root of any type of negative number. Okay, so that's complex numbers. There's more i's. Okay, we're gonna do more of those. They're fun, right? You guys like them? All right. So complex fractions. Go ahead and write that down. B plus 1 over z plus 2m. So we're gonna kind of set aside the b, and we're not gonna worry about it at first. And we're just gonna simplify this fraction right here because we know how to do this part here. And what we do is we create, every single one should have like a fraction. So I'm going to put this over 1, and really in the top we have 1 over 1. So now I'm going to look at all three of these denominators. I have a 1, a 1, and a z. So what is the common denominator of those three? It is z. So we're going to multiply the top by z over 1 and the bottom by z over 1. And this is allowed because I'm really just multiplying by 1, right? So this is allowed. All right, so now I have b plus. So in the numerator, what do we get? We get z. In the denominator, we're distributing. What happens to the z's right here? Angela, what happens to the z's here? Yeah, they cancel out and we get 1. And now I have a plus sign, so plus. And now I'm multiplying these together, and Raina, what do I get here? 2mz. Awesome. Okay, so we all hopefully remember how to do that part. Now we're just adding the b with it, and we're going to do good old-fashioned common denominators. That's it. So b is over 1, and it's missing this entire thing. So I need to multiply the first fraction by 1 plus 2mz over 1 plus 2mz. Again, this is allowed because I'm really multiplying by 1. Go ahead and distribute the b, and now I have it all over common denominator. So I have b times 1 is b. Now I'm going to multiply the b here, so plus 2bmz, and then plus z in this second part, all over my common denominator, which is 1 plus 2mz. So simplify the complex fraction, get a common denominator, and you're good to go. That's as good as it gets. As simplified as possible. So let's try another one. I have s over z plus 3 over 5 plus 2s over z. So really, we're going to put this over 1, and we're going to put this over 1 so that I have all fractions. So Nate, in this first fraction, what is the common denominator? Good. Good job, Nate. All right, z over z. That was like perfect unison. All right, z over z. So now I have s over z plus. All right, Kara, what do I get here in the numerator? 3z over. Stephen, what do I get when I multiply here to here? Nice, 5z plus. Sam, what happens to my z's here? Nice. S. Good. Common denominators, okay? These are two separate things. Anytime you have a plus sign, this is an entire term, all right? So that's all friends. So that means I have to multiply the first fraction, Sydney, by what? Yep, 5z plus 2s over 5z plus 2s. And Bailey, what am I going to multiply the second fraction by? Yep, z over z. All right, so over over here we can go ahead and distribute. So Hugh, what do I get when I distribute the S?
5ab plus 2.
Good. All right, and then I have plus this part here, which is 3z squared. Okay, all over my common denominator, which we do not multiply out, and usually we put the monomial first, so we usually put the z in the front, and then 5z plus 2s. And that's it. Simplify. All right, you have to do the i's first, or you're going to get the wrong answer. All right, i's first. Think I. Think I. Let me see these. So each of these has an I that comes out because each of these has a square root. All right, so I'm going to take out the negative sign that's under the house. So this becomes an I root 2. And I'm going to take out the negative sign that's under the house. So this becomes an I root 3. Now we can multiply them together. So the i's multiply together and we get I squared. And the 2 and the 3 multiply together and we get 6. I squared is -1. So we get negative root 6. Had you multiplied those numbers first, you would get the wrong answer, all right? Because it would become +6 and you wouldn't get the i's. So you have to take the i's out first, all right? Do it first. Okay, simplify. Yay, more of these. Okay, hopefully we still remember all of these little things. If not, let's write them up here. I squared is -1. I to the third is -I. I to the fourth is +1. After that, it iterates. These are the main ones we want to remember. And we leave I as I. Okay, we leave I as I. All right, so I to the fourth. Dan, what's I to the fourth? It is 1. So we're going to replace this with 1. Now I have -5. And Lindsay, what's I cubed? So we're going to replace this with -I. -3, and we have to pull the i's out from each of these, just like we did in the last problem. So this negative sign, we're going to take the I out, and it becomes a +3, and then we take the I out from this one, and it becomes a +5. All right, so let's keep on keeping on. So I have a 1, and I'm going to multiply these together, and Nate in the back, what do I get here? +5i. All right, and now I have I times I. So let's go ahead and make this I squared, which we will change here in a minute. And we can go ahead and now multiply the 3 times the 5, so I get root 15. All right, so 1 plus 5i. This right here is a -1 that we plug in for the I squared. So this becomes a +3 root 15. Normally we do real plus imaginary, so I'm going to put all of this part together and then put plus 5i. All right. One more I problem that we haven't done yet. And this is pretty easy. It's just like foiling when you have an x. The only difference is that I squared turns into -1. So we're just going to FOIL it out. So Anna, what do I get when I multiply the first times the first? 12. Landry, what do I get when I multiply the outside? Good. Ian, what do I get when I multiply the inside? Plus 20i. And Ethan, what do I get when I multiply the last? Yeah, -25i close. I what? times I is I squared. All right, so combine like terms. So this becomes a plus 5I. I squared is -1. So this turns into what, you guys? Plus 25. So that becomes a real part. So we can actually now add these together, and we always want to end up with real plus imaginary. So this becomes 37 plus 5I. So you should always end up with an A plus or minus BI for that part. And we're good to go. All right, let's try it.